Welcome to the tutorial for working with large data in Blender microscopy. Working with Blender with large volumes in general will be easier on a competent computer. So either if your lab has a workstation or a very modern laptop. I run a lot on an M1 MacBook Pro, but even this is starting to get a little bit outdated depending on what I try to do, how complicated the scene gets, and how much work I expect the machine to do with rendering. But how Microscopy Nodes is built is that we can do a lot of things on a slightly weaker machine and then only go to large data later on in the journey. So for this, I'm first going to delete everything in the scene, like we do with loading data, and then load an OMESR data set. So with an OMESR data set and Microscopy Nodes, but also with a large TIFF, because there will all be automatic downsampling, is that we can select our different scales. So we can go first with a very small scale, and this should be easier to work with. And then later, once we've made our whole animation, we can say, let's reload. And so for reloading, you need to make sure that the object that you want to reload is the data set you want to apply this to. Reload this with a higher scale, and this can go all the way up. However, the reload will also by default apply all the settings that have been changed in here. So we can, for example, if we change the colors, this will affect how things are being shown. If we want to turn that off, we can say we can turn off the update settings button, and if we want to turn off updating the data, we can also only update the settings. But there is still the issue that we often have with our large data, that we don't actually care about the resolution of the complete data set. And so for this, we have masked sparse reloading, where we can select a region and only load that specific region at a high resolution. And this is all under this I button, but to first get there, we need to first build a mask. And so I have a longer tutorial on more advanced masking, but for now we will just switch to geometry node slicing and reload our small data set. Our slice cube will create a mask of which voxels are being visualized. If we then select a small region that we're interested in, so for this data set, for example, I know that there are in here, somewhere there are actually the centrioles, and they are slightly hard to see, they're here, but with this low resolution we don't really get the complete picture of how the centrioles look in this expansion microscopy data set. So what I'm going to do, I'm going to grab the slice cube, I'm going to scale this down, and then scale it up in Z by doing scale by S and then Z to lock it in the Z axis, and find, by moving it with G, the centrioles. So now I have a mask of specifically where my centrioles are. This does not have to be based on the slice cube, it just needs to be within the geometry nodes of the volume, that the endpoint after all the masking here, without the shader being applied, is actually the voxels you want to reload. So if this is a label mask, or if this is based on an isosurface, this should also work. So for example, in this, instead of making the small box, I could also make a isosurface of the centriole channel, the acetylated tubulin channel, and use this to reload the data. But right now we'll use the box for convenience. And then we can go back to our load panel and press reload only visible, this I button. And by default it will already turn off the application of the settings. This means that only the voxels that remain after spatial masking will be reloaded into the higher resolution. So if we now go to our highest resolution, it will make a map of all the voxels that we currently have active and ask for only those from our dataset. This is slightly slow because there is some disconnect between the loading from ZAR and writing to local files. So be warned that this might take a while, but after that you will have quite a responsive thing with high resolution. So I'm going to press reload right now with the largest resolution and only the centrioles selected. Okay, with our high resolution data loaded, we can start to see that we have much nicer separated centriolar data, and we can also start to really see the fibers of the microtubules. And we will see also that if we make the slice cube bigger again, that we will actually do not have the data that we first had there. I'm going to make this small again, just Control Z. Because I kind of want to show both scales at the same time. I want to also have the whole cell, but just so the centriole in this amount of detail. So for this, I'm going to turn off the reloading of the individual object and just load a new small copy of our data set. And then we see that we have our high resolution data in our low resolution data. The only issue with this is that it's completely duplicate in here. So we can do much more of like going back to what we learned in the masking tutorial. We can start to say, okay, let's only take for our new data set, which is the 0.001. We can start to say, let's take another slice cube in series where we say it needs to be outside the first slice cube. And similarly, we can do that for all channels. And this will make it that if we turn off the visibility of our first data set, we will see that there is effectively a hole in our other data set that is exactly the size of that single chunk. And we can then start to we could make an animation where we zoom into our centrioles, specifically into this region. Turn back on the NHS in here, and the only issue is then shading these so that they either are the same or that they look the same. So in this way, we can take small regions of a data set either by very flexible masking, so we can do something with a with a complicated shape we can also select, but we can also just crop a box and say, let's reload this box, and still have all of our data that's around it still being visualized at a different scale. And all of this is extremely editable, even if it is slightly manual to set up. Once we have this set up, we can actually just use this. So I hope this helped for learning how to interact with large data. Please note that every single mask you make we'll take the voxels of the scale that you're currently at. So if you do the reloaded voxels from already a really large size, it might be a little bit heavy. So I would always recommend, if you want to rescale your mask a lot, you go intermediately to a low scale and then go back to your high scale. And we can also, I will just quickly turn off every channel that we're not interested in both of our volumes. And here we can maybe appreciate even more what the difference in resolution is really like between these two different sizes, and we can see how we can kind of start to combine these things. Thanks for watching. I hope this helps with large data loading.